Hello, this is Mrs. Scarpel, and in this video I'm going to review the concepts of interquartile range, mean absolute deviation or MAD, and standard deviation. Interquartile range is specific to box plots because that's when we have the data separated into quartiles, where the same number of values is represented in each of the four sections of the box plot. But based on the width of those sections will determine the variability. With box plots, especially when they're skewed, we'd be looking at the median as our center of measure that is most reliable. And for that reason, we use the interquartile range, which finds the difference between Q1 and Q3. And typically Q3 is going to be the larger value, Q1 is going to be the smaller value. So that's why we say that the interquartile range is Q3 minus Q1. So if we take a look at August here and the miles driven each day in August, our IQR for this particular box plot is going to be 60 minus 20, which is 40. If we take a look at September, that's taking us from one end of our box to the other. The IQR is going to be 70 minus 10, which is 60. For October, if I do the same thing, my interquartile range, my IQR, is going to be 70 minus 20 is 50. If I look at November, my IQR is going to equal 70 minus 30, which is also 40. And then in December, my IQR is going to be 50 minus 30, which is 20. So looking at these values, I would say that December has the least variability because it has the lowest interquartile range value. So most of the data, or I should say 50% of the data, is right around our median. That's the other thing about these box plots. These box plots contain the middle 50% of the data. Now, the one with the most, if we look at our values, is going to be September because it has the largest interquartile range. So this has the most variability of all of our box plots, or of all of the data for the 5 months. So, and again, variability is the amount of spread. How far away are the numbers spread away from the measure of center? In the case of a box plot, we're looking at what is that spread in relation to the median. Now, I mentioned two other measures. We have the mean absolute deviation, which is MAD, and what we would do there is we would find the mean of the values we have. We'd find the distance away from the mean for all of the values. And since we're looking at distance, we'd want all of the positive values. And then we find the average of all of those distances. That's what gives us our mean absolute deviation. Standard deviation also has a method, but we used the standard deviation for population feature of Desmos to calculate it. There is a formula for it, but we aren't going to worry about that in this particular class. What you need to remember about both of these types of deviation is that they are both measures of deviation from the mean of a data set. So how spread out is the data from the mean? The larger the MAD or standard deviation value, the more variability there is going to be in the data centered at the mean. The smaller that MAD or standard deviation value, the less variability there is in the data centered at the mean. So let's take a look at some box plot or some dot plots, excuse me. And we're going to take the time to place these dot plots in order of variability from least to greatest. The one that's going to have the least is going to be B, because all of the values are the same, and we would say that this has a standard deviation or even a MAD of 0. So B has the least variability. The one that is spread the most is A. Our center is here at 16, but you notice it goes out quite a bit further on either side of that. So A is going to have the greatest variability. D will have the second lowest variability because we've got everything within these 4 values, and it is symmetric. So D is going to be the second one, and then that leaves C for the third one. C is not spread near as much as A, even though we have a number of columns. They're all pretty much centered around our 26, which is our mean and our median, since this is symmetric. These spread out a bit further from the 16. So when you get closer to having them all the same value, you're going to be closer to having a variability value of 0. When you get further away, that variability value is going to get a little bit larger. And this concludes my quick review of measures of variability.